Good morning. Welcome to the 5th webinar in our Maths Methods Student Revision Series. This webinar is looking at Mathematical Methods, Unit 3, Further Calculus and Integration using the TI-Nspire. I'm Melissa Hurrigan and I currently teach at Marumba State Secondary College in Queensland. Our learning intentions for this webinar are we'll revise how to graph a function, which we have seen over the last couple of days. And our focus then is finding the value of a derivative at a point. As well, we are going to look at graphing a function and then finding the value of an integral. And we're going to use graphing and calculator pages to solve problems involving both differentiation and integration. So before I start looking at some particular questions, I thought it a good idea to just quickly revise what options that we have available to us on the calculator when we are looking at derivatives and integration. So the first one here is looking at how we find the value of a derivative when we're using a graphing page. So we've got the option with our calculators to use a graphing page. And in that one, as with all parts of using the calculator, we use the menu and it gives us the options then to analyse the graph, and we have the derivative as an option, so dy dx as an option there. The other option if you are doing graphing is using a graphing page is that you can go down to the geometry option in our menu and choose points and lines, put a point on your graph and then have the calculator draw the tangent at that point, and it's going to give you the equation of the tangent. So that's another really helpful option there in a graphing page. Also with derivatives, we have the option on our calculator page. This one uses the template key and the derivative template and will provide us with the value of the derivative at that given point by using the such as constraint. And we're going to look at each of these options in this session today. So those are our options for derivatives. And our options for the integral, we need to remember that because we are using a non-CAS calculator, it's not going to do the algebraic work that a CAS calculator will do. So what we are getting when we do the integral of a function on either the graph page or the calculator page is we're getting the numerical value of the integral. And we're going to talk about that as we're working our way through. So there's two options there. Again, the graph page, going through the menu, analyze graph and integral, or using calculator page and again using the either calculus, numerical integral, or using the template and inserting the integral template onto our page. So again, we're going to look at those in our questions. So what we might do is get started on our first question for today to look at the basic skills. I'm going to look at a couple of derivative questions first, and then look at a couple of integral questions. So let's get started. So the first question we're going to look at today, as I said, very basic question here on finding the derivative at a given point. And I'm going to use, obviously, our graphics calculator to do that. So if we're given this particular question in an exam, and it could be a multi-choice question in a tech active exam, or it could be part of the short response paper in a tech exam. One thing that is suggested, and we have looked at in each of the previous webinars that have been done in this student revision series, is using a document and setting up one document for the exam. So I'm going to follow that same process. So I'm going to start a new document. I have been using my calculator recently, so it had a document there. I don't want to save it. And I'm going to insert a calculator page. So I'll choose option number 1. So I'm going to start this question by doing it with a calculator page, and then I'll check it using a graphing page just to show the two different versions. So as I said before, with our calculator page, I need to use my template. Now I've got two options. The template key is next to the number 9 key on my keyboard. Beside that, the picture of the book is looking at the catalogue. And what I can also do is to type the letter D, and you can see here it shows derivative. And the good part about using the catalogue is that it does tell us, well, how do we need to set this up. So we can see here derivative, we need to put our expression in. We need to put our variable that we're deriving with respect to. I'm not going to worry about the order, but this last part here is we need to put in our constraint, our with respect to, or our such that line, our variable again, and the value of the point. If I'm going to use my catalog button, looking along, the derivative is on the second line, and it gives us our what would commonly be called ddx. So I'm going to use this one. So my variable is x. Inside my bracket, I need to put in my equation or my expression. So I've got 4x cubed, making sure I move out of my exponent there. I've got minus 3x plus 7 minus 2 over x. So I've got my expression in. I need to tell the calculator what I'm deriving with respect to. So I'll put a comma and x. So I've now said I'm deriving that expression with respect to x. I'm going to move outside of my bracket, and I need to put my constraint in. So I've got control, the equals button to get my menu here and choose the constraint. And I need to say that x is going to equal, and in this case, I want the derivative when x equals 1. So x equals 1. So I've inserted all of my information, and I'm going to press enter. Now I have a syntax error here. Sorry, I didn't need to have the variable in there. So I've removed the variable x, sorry about that, and it's given us the value at the point x equals 1 for our function there. In terms of answering this on a test, if it was a multi-choice question, we could obviously select the correct answer. If it was a short response, then we would need to make sure that we are making it clear what we did to solve it. So we could actually write in that I was trying to use a pen, but it's choosing not to work for me. So I'm going to leave that option there. We could write in that we've used a calculator page, actually show the syntax of what we've entered. So the ddx in brackets, our expression, and then with respect to x equals 1 to get our solution and then provide our solution. As I said before, what we're also going to be doing is looking at using a graphing page. So I'm going to insert a graph page here. So I use control and then the document key and choose number 2 graph page. What I do is I insert my function. So I'm going to put in 4x cubed minus 3x plus 7 minus 2 over x. And you can use the fraction template to put the 2 over x. But I graph my function, and I want my derivative at x equals 1. So I'm going to go to Menu, Analyze Graph, dy/dx. Now it's asking, see in the bottom left-hand corner, it's asking for the position here. Now I can either move to my graph and hope that I approximately get x equals 1, but the better option is to actually type in 1 and press enter, and it shows us on the graph where the point is and the value of the derivative. So again, we've got that the derivative of our function at the point x equals 1 equals 11. So that's our first question there, straightforward, ensuring that I've got the function in there, I've used the derivatives, and I've used my value of x equals 1. Okay, so let's have a look at our question number 2. So in question number 2, we're moving to using the value of the derivative to find the equation of the tangent to the curve. So we've got our curve of y equals 1 plus e to the power of 2x, and we're at the point of 0, 2. Because my question page, my pen that I'm writing with is not working very well, I'm going to go to the larger graphics calculator screen, and this may make it easier for you to be able to see what I am actually doing. So in what I'm doing here, first of all, as I said, we're working through our exam questions, and so I want to hold on to question 1 so I can go back and check it later. And so what I'm actually doing is I'm going to insert a new problem. So problem number 1, I use 2 pages. I'm going to go to Document, down to number 4, Insert, and choose number 1, Problem. And this time I'm going to start with a graphs page. Again, you can use the calculator page, but I'm going to start this one with a graphs page. And notice that it has started with 2.1. So that's question number 2. So the first thing I need to do to find the equation of the tangent is I've actually got to know that the tangent is a linear function. So it's y equals mx plus c. So I'm going to need to know my gradient, and I'm going to need to know my y-intercept. So I've actually already been given my y-intercept because we want the tangent at the point 0, 2. So I need to find the gradient for what will be my tangent line. We know that to find the gradient, it is the value of the derivative at a given point. So that is giving us the gradient at that point. So what I'm going to do is I'm going to put my equation in. So f of x equals 1 plus e to the power of 2x. I'm going to draw that graph. I want to know the gradient of the tangent at the point 0, 2. So I'm going to go into my menu, choose Analyze Graph, choose Derivative, dy/dx, and again, it's asking for the position. Now, the good point with this one is that I can actually see where my point 0, 2 is. But just to make sure, I'm going to type in 0, and that's going to give me the gradient at that point. Just going to move it slightly. So that tells me that my gradient for my tangent is 2. I also need to know my y-intercept, and given that my point is at 0, 2, I have a y-intercept of 2. So I have a gradient of 2, and I have a y-intercept of 2. So putting together my equation for my tangent, y equals mx plus c, I'm going to have y equals 2x plus 2. Now I can check that again by doing menu. This time I'm going to go down to geometry and choose points and lines. Because I've already put the point on the graph at 0, 2, I don't need to do that step. However, if I had not placed the point on the graph already, my first step would be to choose point on and to place the point at 0, 2. My second step is to then choose option 8 here, which is tangent. And I go to my point, and we can see that when I move close to the point, because my point is already on there, the calculator actually gives me the tangent, and it actually also, whoopsie, it also gives me the equation of my tangent. Now, we saw that I went to move the length of my tangent, and it actually changed my graph, and that's because it's still trying to work with putting a tangent on it and changing the point, so I need to press escape to get out of that menu function. And I can, if I want to, make my tangent line much larger. But we can see that the equation of our tangent is y equals 2x plus 2. Again, I could have used a calculator page, completed the derivative using the template to get the gradient of 2, and then knowing that my y-intercept was also 2, I've got y equals 2x plus 2. So that's our second example of what we may need to do in an exam question. Again, you need to be communicating the process that you're following. So I would be making sure that I acknowledge that the tangent is a linear function. So I could actually show you this using a notes page. So we can say that the tangent is a linear graph, and therefore y equals mx plus c. We need to acknowledge that the gradient is equal to the derivative at the point. So we're going to have the derivative at x equals 0. By doing the derivative, we get that the gradient equals 2. And then we need to insert our point. So in this case, our y-intercept, where x equals 0, we get y equals 2. So therefore, we get y equals 2x plus 2. It's just making sure when you're answering questions that you are communicating what it is you are doing to answer those questions, because marks are going to be given for providing that important information. All right, we'll move now to our third question, our third example. So looking at our third example is that a particle moves along the x-axis with its position at time t, given by x of t is equal to e to the power of t sine of t for t between 0 and 2 pi, and we want to calculate each time for which the particle is at rest. So we're going to again use a graph page for this one. Again, this is my third question, so I'm going to insert a new problem. And as I said, we're going to use a graph page. So the first thing I need to do is to graph my function. Now, because I'm on a graphs page, my variables here are x and y. So what I need to do is, in my mind, reform the question. So instead of it being x of t, I need it to be a function of x. So where there is t in my question, I'm going to be replacing that with an x. So the original question was e to the power of t, so I need to have e to the power of x. I'm then going to multiply that, so I need to move out of the exponent position, and I'm going to multiply that by sine of x. So I go into my trig, choose sine and x, and I'm going to draw my graph. Now, we're also given the constraint in the question that t is between 0 and 2 pi. So that means for this one, I need to have that x is between 0 and 2 pi. There are two options for changing the scale on my horizontal axis. One is to click on the actual endpoint. So at the moment it goes from x equals -10 to x equals +10. So one option is to double click onto your endpoints and change that. Now, I always like to have my two axes in my picture. So although my constraint is between 0 and 2 pi, I'm going to go to -pi and I press enter. The other option is to go into menu, into window, and change the window setting. -pi has stayed there. I'm going to change my maximum. Now again, I'm going to go just beyond the 2 pi that I need. So I'm going to go to 3 pi. And the nice part is I can actually type in pi, given that I'm on a computer, or on your calculator, you have the pi button down next to the letter H in your numerical keypad at the bottom. So you can choose pi there. So you've got two options there. I'm going to press tab to go down to auto, and I'm actually going to scale it with pi on 2. So I'm going to do pi divided by 2, tab down. I'm not too worried at the moment as to my minimums and maximums there. So I might just leave them for the moment and tab down till I get to OK. Now what I can see is actually my maximum's a bit out of screen there. But what I need to remember is I'm working on each time for which the particle is at rest. So we need to remember that the particle is at rest at a stationary point or a point of inflection, and that is when the derivative is equal to 0. Now we also know that the derivative equals 0 at our minimums and our maximums. So what I'm able to do is to actually use menu, analyze graph, and actually use the minimum and the maximum. But I've got to be a little bit careful when I'm doing this, because the calculator will give you whatever the minimum value is in the section that you choose. So we'll see that in a moment when I look at checking for all of my possible results. So I can see here that from x equals 0 up to x equals 2 pi, I've got a few values there I need to be aware of. So I'm going to go menu, analyze graph, and I'm going to do the minimum value first and just see what do I get between my value of 0 and say my value of pi over 2. And it's actually giving me the minimum is at 0, 0. But if we look at our graph, notice that the graph does go down further than that. But remember, that horizontal axis is representing time, so we're not worried about any values in this negative part here. So our first point of rest is at 0, 0, which is our starting value when time equals 0. The next thing we need to have a look at, we can see the graph goes up and goes to a maximum. So what I'm going to do now is use my menu, analyze graph, and do maximum. And I'm going to go from my pi over 2 up to my 3 pi over 2. Notice that the calculator automatically rescales the graph so we can see that maximum point, and it gives us the value of x equals 2.36. So we're going to need to remember that. Now, because the question has been given to us in radians with a domain of 0 to 2 pi, we should be providing our solutions in terms of pi. So we do need to be aware of that. And what we can do is to go to a calculator page and we can put in our 2.36. Now, please remember, I have got an approximate answer there. It is rounded. Now, I can either choose to divide by pi, which gives me that it's 3/4. Okay, so that means that it's 3 pi over 4, because it's 3/4 of pi. Or I could choose to convert it to a fraction using my menu number and approximate to fraction. Doesn't give me a very nice option there. So my best option is to use that I've got 0.75 of pi and leave it as 3 pi over 4. I'm going to go back and we can see that too, that the 2.36, remember pi is at approximately 3.14, so it's less than 1 pi, hence the 3/4 pi. Now I've been asked for where it's at rest between 0 and 2 pi, so I need to remember 2 pi is approximately where my cursor is currently sitting. So I need to do a minimum here as well, or at least check that whether there is minimum. So I'm going to go to Menu, Analyze Graph, choose Minimum, and I'm going to go close to pi, up to my 2 pi, and it shows us that there's definitely a minimum. It doesn't give us a very good looking graph there, but we can see that there is indeed a minimum at approximately x equals 5.5, so our time of 5.5. And again, I can go to my calculator page, do 5.5 divided by pi, and it's about 1 3/4. So that's 7 pi over 4. So I've got my two options there, as well as a starting point of t equals 0. I've got a maximum or a stationary point at 3 pi over 4, and I've got a stationary point at 7 pi over 4. Okay, we'll move now into our fourth example. This one we're going to start looking at integrals because we've been given a derivative here. So rainwater is being collected in a water tank. The rate of change of volume with respect to time is given by dv dt equals 5t plus 2. So our derivative is 5t plus 2. The volume of water that is collected in the tank between the times t equals 2 and t equals 6 is equal to what? So we need to go from our derivative back to our volume. Now what we're actually able to do here, there's a couple of different ways to answer this question. I'm going to show you the graph page for an integral, but I'm also going to show you how you can use lists and spreadsheets for this particular question. So first of all, I'm going to insert a new problem. So document, insert, and problem. Very quickly, a graphs page. I'm going to insert 5x plus 2. And I'm going to use analyze graphs, this time integral. The lower boundary, the question says t equals 2. The upper boundary, where t equals 6. And it gives us there that we've got 88. So we've got the integral there between two boundaries, between 2 points. Okay, so what we've got to look at is that it's telling us that the amount of water that has been collected is going to be 88 litres. Now we're going to see how you can also use the list and spreadsheets page to do this question. And I'm going to explain how you would do this without worrying about it being integral and area there. So I'm going to insert a list and spreadsheets page. And if you think about this particular question, When we've been given a derivative and we want to find a change in volume, what we need to look at is integrating. So we're practicing our skills in integration. So I'm going to insert my time, and I'm actually going to use the word time rather than just t. I can use t there as the label for that column, but the issue I'm going to have is when I ask for column B for the spreadsheet to do a calculation, because if I use t, it's going to ask me, is that a column reference or is that a variable reference? So to eliminate that misunderstanding there by the calculator, I'm actually writing in time. So we've got time equals 2 and we've got time equals 6. And then I'm going to go up to the top of column B and I want volume. So I'm going to call it VOL. Now, to work out the volume, I need to integrate my function. So I need to remember my process for integration. So 5t is going to integrate to 5t squared divided by 2. So I press enter to get the formula bar in, and I'm going to do 5, but instead of t, I need to write time. So I'm going to do 5 times the time, and it goes bold to recognize that, yes, I've defined that variable. And I'm going to divide that by 2. Whoops, I should have put my squared in there first. So time squared, then I'm going to divide by 2. And the plus 2 is going to then become plus 2 multiplied by time. So the 5t integrates to 5t squared over 2, and the 2 integrates to 2t. So now it gives us the volume at the 2-second mark. So there was 14 litres in the tank at 2 seconds. There was 102 litres in the tank at 6 seconds. And to find the volume of water that's collected in that time, I need to subtract. So just going down to another cell, I can do 102 minus 14. And it didn't like that one, because I forgot to put an equal sign at the beginning of it. So it works the same as a list and spreadsheet. So just the same as if you're doing Microsoft Excel, you need to put that equals in to get the spreadsheet to do a calculation. Okay, so it gave me my answer of 88 there. So we can actually use not only our graph pages and our calculator page, but also lists and spreadsheets can come in very handy. And I think the lists and spreadsheets is probably a page that's not used as commonly by students, but I always like to show my students ways of using all parts of the calculator. Okay, we've got one more question to go. So looking at question 5, the last one here, very straightforward integral. I'm going to use a calculator page to start off with, and then again, show the process using a graphs page. This is question 5, so I need to insert my new problem to make sure that I'm keeping track of all of my questions in my exam. As I said, I'm going to use a calculator page to start with. To use a calculator page, I need to use my template key, or again, I could go to my catalogue and type I for integral and find integral in the list, but I'm going to go to my template. Looking at my template on the second row, on the far right-hand side, I've got my integral template. So it looks the same as the integral in the question. I need to fill in my lower and upper boundary. So I've got 0, use my up arrow to go to my upper boundary, and I can type in, again, pi divided by 2, or I can use the pi button next to the letter H. I'm going to use my right arrow to move to where I need to put my function. I'm going to put this in brackets. It does, the calculator automatically puts brackets in, so if you do forget, it's not a problem. So I'm going to have cos, and remember we can type cos or we can use the trig button. So I'll use cos. Notice it opens up a bracket, so I've got to put x in there. I need to move outside of that bracket, put in my plus, I need to go sign, and just to show you, I'm typing sign this time. If I type sign, it doesn't add the bracket for me, so I do need to remember to add the bracket and then put X in. So I've now got my expression, and I need to advise the calculator what we are integrating with respect to. Well, there is only one variable here, and that is the X. So I'm integrating with respect to X, and it gives me my answer of 2. So we can see here that the integral from 0 to pi on 2 of cos X plus sin X dx is 2. And as I said, very quickly to look at that in a graph page, to insert a graph page, I need to put in my function. So I need to insert cos X, move outside of the bracket, plus sin X, and press enter to get my graph. We're going from 0 to pi on 2. I'm not going to worry too much about rescaling this one, but if I needed to, I would change my window settings. I need to go menu, analyze graph, integral. My lower boundary is 0. So I type 0 and press enter. My upper boundary, because I don't have my X scaled in terms of pi, I'm going to actually select pi divided by 2 and press enter. It shows us the area and gives us our integral, remembering that this is the numerical integral. So what we've looked at there today is how to derive our functions and find the value of the derivative at a point, how we find the numerical integral using graphing pages, using calculator pages, and we even looked at a listen spreadsheets page to assist us there. I hope that you have found this webinar useful. If you've got any questions, you're welcome to email, contact your teachers, access the TI student blog, which is a great source of help and information for you. Thank you for joining us, and have a great day.